have two eyes, and if you talk about it technically, so that is called stereo vision, right? So I thought, oh, why not implement this itself as a way for the self-driving car to perceive depth, right? So this specific concept is called disparity. So let's do a quick exercise. So just take your finger in front of you, keep it in front of you, and close your left eye and look at the tip of your finger, right? Just close your left eye and look at the tip of your finger, right? And just keep your hand wherever it is, right? Just don't move it, and interchange your eye, right? Close the next eye and open the other. What do you observe? There's a shift, right? There's a parallax shift. And it turns out that using that, you can perceive depth. And that is exactly what I implemented here as well. So this is the second stage over here. And you can see that there are individual pixel values for each of these components, right? So that is how an image is actually represented. So the pixel range for any pixel is from 0 to 255, right? So from really dark to really light image, right? So you can see over here, if we try to match this point, this is very bright, right? So it's close to 252, which is really 255, right? But let's look at a dark point over here. So this one, right? So this is 0, which means it's a 0 pixel and it's a dark pixel. So that is how it's represented as well. So images are digitally represented as two-dimensional matrices, and that's what you can see over here without the pixel overlay, right? So the next one is camera calibration. Right? So we do know that recently ISRO landed the rover on the moon surface. Right? So, and how did this landing happen actually? So there were multiple cameras on the bottom of the rover or the landing module. Right? And even if the calibration was off by 1 millimeter, it wouldn't be able to land. Right? So there are multiple particles on the moon surface itself that are like an obstruction for the landing sequence. So if it's not able to calibrate its system accordingly based on the dynamic environment, then that wouldn't have been possible. Right? So again, that is just an example, but that works out with camera calibration.